Hello and welcome everyone out there. In this video, I'm gonna explain the modern atomic structure and the electronic configuration in a super easy way within just 7 minutes. So just check it out till the end to clear concepts and don't forget to subscribe, hitting the bell icon to get the latest updates every other weekend. Yeah. We all know atoms are the structural units of elements or compounds. It is the smallest unit of matter which can take part in chemical reactions to form a compound. Let's find out the constituents of atom in details using modern atomic structure, which tells us that atoms can be further divided into three subatomic particles that are electrons, protons, and neutrons. Let's compare their mass and charge. Electrons have negligible mass and protons and neutrons have similar mass of 1.6 into 10 to the power minus 24 grams. Electrons have negative and protons have positive but same charge of about 1.602 into 10 to the power minus 19 coulomb. The neutrons have no charge, so it is neutral in nature. These subatomic particles are being represented by the symbols E for electron, P for proton, and N for neutron, along with their mass on the superscript and charge as a subscript, with the sign -1 for electron and +1 for proton. Let's check out the locations of these subatomic particles inside an atom. Negatively charged electrons follow the fixed paths to revolve around the center of the atom are called orbits or shells. Shells have fixed energy levels. Positively charged protons and neutral neutrons forms the center of the atoms called nucleus. Let's talk about shells and electronic configurations in details. Shells or orbits are being represented by the alphabets K, L, M, N. Shells have fixed energy levels. So, if electrons gains more energy, it tends to move to the next shell, like this. Similarly, if energy is lost by the electron, it moves to the previous shell, like this. In this way, the total energy of the shells remains constant. Now, let's talk about the electronic configurations in details. It is the distribution of electrons in different shells like K, L, M, N. The number of electrons in each shell can be determined by the formula 2n square, where n is the number or position of the shell. If the position of shell K is considered 1, then the maximum number of electrons can be accommodated in the shell would be 2 into 1 square, that is equal to 2. Similarly, the second shell L will have 2 into 2 square, that is 8 number of electrons. Like that, third shell M will have 18 and fourth shell N will have maximum 32 number of electrons. Now let's get to know about the valence shell, which is the outermost orbit or shell of an atom. And the valence electrons are those electrons which are revolving in the outermost shell. Valence shell always tries to follow duplet or octet rule. Means it always tries to keep 2 or 8 electrons in the outermost orbit, even though the orbit seems to appear to be in a same plane like concentric circles. But in reality, these shells are located in different planes, so the atoms take up the shape of a sphere. Total number of negatively charged electrons in an atom is equal to the total number of positively charged protons, which is equal to the atomic number denoted by Z. As the total negative charge of the electrons are equal to the protons' positive charge, Atoms are electrically neutral in nature. As the positive protons and neutral neutrons forms the nucleus, it is also positively charged. Protons and neutrons are together called nucleons, and the total number of nucleons are together called mass number, denoted by A. Atoms are symbolized by X superscript A subscript Z. For instance, the symbol of an oxygen atom is O superscript 16 subscript 8, where 16 is the mass number and 8 is atomic number. Before we proceed, please don't forget to subscribe hitting the bell icon. Let's clear out the concepts using an example of aluminium atom having the mass number 27 and atomic number 13, which means it has 13 electrons in its orbits. The first two orbits K and L should have maximum 2 and 8 electrons in its orbit. The third orbit M is having the rest of the 3 electrons, making a total of 13 electrons, and that is the electronic configuration of the atom. As the last shell M is having 3 electrons in its outermost orbit, we can say that there are 3 valence electrons in its valence shell M, and the valency is 3. But if the valence shell is having more than 4 electrons, the valency should be calculated by subtracting the valence electrons from number 8. For instance, nitrogen atom has got 5 valence electrons in its outermost orbit, but their valency would be 8 minus 5, that is 3. Similarly, for oxygen atom, it would be 8 minus 6 valence electrons equal to 2. Like valence electrons, electrons in the shells close to the nucleus are called bound electrons. Finally, from the symbol of an aluminium atom, we can find out its mass number is 27, atomic number is 13. Therefore, the number of protons P and number of electrons Z both are 13. Now, to find the number of neutrons, we need to use the formula N is equal to A minus Z. Here, it will be 27 minus 13 equal to 14. So, there would be 13 protons and 14 neutrons in the nucleus. For more concepts, please check out the end screen videos and the description box. But please don't forget to subscribe hitting the bell icon.